Hey everybody. So we have talked about rational functions. We've talked about continuity when it comes to rational functions. We've also talked about continuity when it comes to polynomials. So technically, really what we're dealing with for this whole unit has really been polynomials and rational functions. So what we're continuing on now is not only are we dealing with the functions portion of it, now we're dealing with our inequalities. And the wonderful thing about inequalities and this section here is there's different areas that you can actually use this for. For example, if you're trying to find what is that actual that give point inside in let's say like weight. If you're trying to weigh a certain object to see how much it can actually force it can take before it actually breaks, you actually can do this part and you can say, okay, the inertia and this function and this right here actually is greater than this number or this equation, so that we can kind of say, okay, well, this is the inertia equation, this is the equation for this function, this item or whatever, and we can say, okay, when it's greater than or less than, and we can graph it out. Again, mathematics is the theory behind the actual what's going on in the real world. The real world part is putting it to application, the math that we're learning, that is theory. So with that, as we're going through everything, this wonderful part here is, again, real life situations that actually we're just pulling in to figure out the theory, and then we can apply it to the real world. All right, so here, what we're going to be looking at is actually using a calculator to help us to find it out. So before we actually do this, this lesson is going to be sectioned into two. It's going to be the graphing portion, and then there's going to be the algebraic portion, where you actually have to solve things out algebraically to find the values and the answers. So especially if you plan on going off the calculus, AP Cal, they expect you to be able to not only do problems, solve problems, and actually analyze problems graphically. They want you to be able to solve and analyze problems algebraically, verbally, and also written out. So with that, you need to make sure you can do all of them. So that's what we're kind of doing right now. We're getting you prepared for that. So if you're planning on going off the AP Cal, you'll be doing it, because this is, again, pre-Cal. All right, so with this, we're dealing with rational and polynomial inequalities. With that, because we're dealing with graphing portion for this first part, today is going to be graphing. I'm showing you two different types of calculators that are free that you can use on your phone. So for the Android calculator, or on the Android phone, you can go to RabbitEmu, and that's actually a free calculator there that actually will pull up, that will look exactly like the TI-84. So it looks exactly like that calculator right there. And then you can also go to, on iPhones, go to Calculate 84. Now the reason why I'm telling you guys this is, again, because when it comes to stuff outside of here, like when it comes to the ACT, SAT, when it comes to any of those tests that allow you to use a calculator, it's not going to be, oh, you can use Desmos and work it out. That's not what they're going to allow you to do. You have to use the 84, 83 calculator, or one of those calculators. So with that, today, as we're going through this lesson, I'm going to show you guys how to do this with Desmos. I'm also going to show you how to do it with a TI-84. So that way you have both of them, so you understand how to use both. So that way you cannot say nobody showed you how to do it, but it's here for you. All right, so I'm going to show you both of them. So let's go ahead and start into a lesson. And if we will go, that would be wonderful. Let's go to our lesson. There we go. So again, we're solving graphically this time. Solving inequalities graphically, the rational and polynomial. All right, so with that, we're going to start off with our first equation here. And again, we're not doing any type of algebraic things happening. We're not subtracting 15 from both sides. We're not moving the 15 somewhere, and we're not moving the 2x plus 2x squared plus x to the other side. We're leaving exactly as we have it. So with this, I'm going to show you two ways that we can do this. So first off, I'm going to put the equation into Desmos. I'm going to put the first equation in, the 2x squared plus x in here. But then I'm also going to put the second equation, which is y equals 15. All right, so with this, where's my y equals 15? I'm not there yet. Let's pull you up. You back. There we go. There we go. All right, so we are looking at this function. It says 2x, well, this inequality, sorry. It says 2x squared plus x is greater than 15. When we're looking at this function, we're looking at where this function here looking at where 2x squared plus x is greater than or bigger than or more than 15. So not equal to 15, not less than 15, but greater than 15. So that's what we're trying to find. So if we were equal to, that means we're like at the spot where it intersects, the two lines intersect or two functions intersect. But we're not trying to find that part. We're trying to figure out where that part, 2x squared plus x is greater than 15. So if we look at Desmos here, we have this point here. We have this point here. These are points where they intersect the function, where they intersect. So at -3, 15, and 2.5 and 15 is where they intersect. So I'm going to write this out. So these functions intersect at -3, 15 and 2.5 and 15. So these are ordered pairs where they intersect. But when we start talking about our x values, it says where 2x squared plus x, we are looking for where our x values, where our actual function is greater than 15. So I'm going to write that out too. So we're finding the x values where the function is greater than 15. And we know that it's greater than 15 because it's above 15. So the only parts that are greater than 15 or above 15 are these portions here. And we know that it continues on because it's a parabola. It's a quadratic function. It goes up forever unless there's something that intercepts it, but really there's nothing here to intercept it, to stop it. So here, what we're going to look at is, going for pretty much our domain is what we're looking for. So we'll find our x values. And I'm going to write this here. Finding our x values, our domain, where the function is greater than 15. So if we're looking for our domain, and let me write this out, domain. Our domain for this function will be from negative infinity, because we have an arrow here, negative infinity to -3. And 2.5 to positive infinity. So we're looking at where that function is going to be greater than 15, and our x values, in other words, that are greater than 15, our domain. And so that's from negative infinity with our arrow, all the way until we get to -3. We do not equal -3. Don't put a bracket there because that's when it equals 15. We're not trying to find out where it equals. We're trying to find out where it's greater than. So therefore, we put a parenthesis there because that's where it equals 15. And then again at 2.5, we put a parenthesis there because that's where it equals 15. But then above that is where it actually is bigger than 15. So that's when we go to positive infinity. All right, so I'm going to show you guys this again in the calculator, in the TI-84, and then go from there.